Okay, now we're talking about the midpoint of a segment, and a midpoint of a segment is a point that divides the segment into two congruent segments. We have the congruence symbol right here. That just means it breaks it up into two equal parts. So if I have AB and a midpoint M, the midpoint now breaks this segment into two congruent parts. So I can say that AM, the segment, is going to be congruent to MB because M is that middle point. It's the midpoint. When we're talking about measures, we would write AM with no bar over it is equal to MB. So now we're talking about numbers here. And here we're talking about congruence. So just that the symbols match. Then the segment bisector also talks about okay, now we're going to look at the definition of a segment bisector. So a segment bisector is a point, line, ray, or segment that intersects a segment at its midpoint. So I have my segment in this image, CD, and I'm saying, in this case, let's say we have line L is a segment bisector. So if line L is a segment bisector of our segment CD, then that means that line L will have to go through, and I'm attempting to say that that's the midpoint right there. Line L will have to go through the midpoint of CD. So line L goes through the midpoint, so line L is a segment bisector. It cuts CD into two congruent parts, CM and MD, so two equal parts. Then we're going to use that and what we know about the midpoint to help us answer the next question about PR. So we have Q is the midpoint of PR. So I have PR and Q is the midpoint. So it's in the middle. Now we need to find PQ, the measure of PQ, QR, and PR. So you see how they don't have little lines above them? That just means we're looking for a numerical value for these now. One thing I need to note is what the actual question would include is that PQ is 6x minus 7, and QR is 5x plus 1. That would be given to you. Since they said it was the midpoint, I know that I have two congruent pieces here. If I have two congruent pieces, I know then that PQ should be equal to QR because Q is in the middle. If I know that PQ and QR are equal, that means 6x minus 7 and 5x plus 1 are equal. And I can solve for x. I can add 7 to both sides. I can subtract 5x. And I get x is equal to 8. Just like before, we want to solve for x first, and then we want to plug this x value in so we can actually figure out what PQ is. So PQ is 6x minus 7, but it's also 6 times 8, which is x, minus 7. So it's 48 minus 7, so PQ is 41. I also need to find, so I need PQ, QR, and PR. So QR is 5x plus 1, so that means it's 5 times 8 now, plus 1. So QR is 40 plus 1. Okay, so I found 2 out of 3. Now we got to look at PR. We have to remember that PR is this whole. And when we have a segment and it's cut up into 2 equal parts, we know that the part plus the part should equal the whole. So PQ, the part, plus QR, the part, should equal the whole PR. So part plus part equals the whole is the whole idea of the segment addition postulate. And I know that PQ and QR are both 41, as they should be because they're equal. So then that means PR equals 82. And we'll practice this more in class.